Brisbane's financial heart pulses through gleaming towers along the river. From the outside, the skyline projects pristine corporate strength. But this city sits squarely in a Köppen-Sea subtropical climate zone. With relative humidity hovering between 65 and 85% year-round, the very air creates an ongoing battle for commercial architecture. The conflict begins at the building envelope. You have heavy, moisture-laden outdoor air at 28 degrees Celsius pressing against a structural shell that's aggressively chilled and dried by internal air conditioning. When that warm, tropical outside air infiltrates the building and touches a cold internal frame, it condenses instantly. Those tiny droplets of water are all it takes to trigger a biological reaction. They serve as the ignition source for rapid mold proliferation. The real threat rarely appears as an obvious stain on a lobby wall. The spores breed unseen in dark structural cavities and mechanical spaces, quietly degrading the building's air quality long before anyone notices a problem. Operating a skyscraper here means rethinking standard maintenance. You can't just cool the air, you have to actively intercept the moisture before it sparks a toxic outbreak. The problem accelerates at the mechanical intakes. Towers situated near the Brisbane River pull heavily humidified air directly into their ventilation systems. Inside, that wet air collides with HVAC cooling coils operating between 8 and 12 degrees. The coils act as massive dehumidifiers, stripping water out of the incoming air at a relentless pace. All that extracted water drips down into shallow collection pans. In the ambient heat of an enclosed plant room, these pans quickly back up, leaving stagnant pools sitting in the dark. Within weeks, a neglected drain pan becomes a biofilm incubator. A thick matrix of bacteria and organic debris forms, providing a perfect nursery for high concentrations of fungal spores. As the system pushes freshly chilled air past these pools, it picks up the newly hatched spores, blowing them straight through the ductwork and out into the open plan offices. Unless those pans receive regular chemical flushing and UVC germicidal treatments, the building's mechanical lungs actively seed the entire tower with mold. The moisture that makes it past the vents eventually settles down into the floor. When winter arrives and the cooling systems power down, ambient humidity absorbs straight into the carpet and soft furnishings. Standard steam cleaning actually makes this worse by soaking the underlay and creating a new breeding ground. Managing subtropical offices requires low moisture encapsulation chemistry, where a polymer crystallizes around the soil so it can be extracted without saturating the subfloor. The threat also attacks from the perimeter. Every afternoon, the western-facing facades of the financial district bake in the intense Queensland sun. Solar radiation takes moisture from the exterior skin and drives it into the wall framing. Inside, hot, wet air hits the thermal boundary, where exterior heat meets chilled interior drywall. The air cools instantly, dropping water into the dark framing. Because standard commercial building materials absorb this water easily, these sealed interior spaces quickly rot, turning the walls themselves into hidden sanctuaries for fungal colonies. Stopping this cycle requires active forensic tracking. Specialists pull air samples from multiple zones to measure airborne load, checking to see if the environment exceeds the safety baseline of 1,000 colony-forming units per cubic meter. They map the office floors with calibrated hygrometers, scanning behind walls and above ceilings to locate isolated dead zones where relative humidity secretly creeps past 70%. This flowchart shows a dedicated outdoor air system, or DOAS. It's a mandatory engineering upgrade that captures fresh external air and physically strips the water content away before it can ever mix with the recirculated indoor supply. Because the outside air is so warm, towers here rely on specialized desiccant dehumidifiers. These systems extract the heavy water vapor directly using drying agents, avoiding the massive energy waste of trying to freeze the humidity out of the air. You cannot safely regulate the temperature of a subtropical building until you have mathematically conquered its internal humidity profile. The final line of defense against the climate is the skyscraper's outer skin. Engineers utilize a mechanical strategy known as positive pressurization to turn the building envelope into an active shield. By precisely tuning the HVAC system, the internal air pressure is kept slightly higher than the air outside. That higher pressure physically pushes outward against every window frame and door seal, repelling the humid air trying to seep in. But that pressure defense completely fails if the ductwork joints and exterior facade penetrations are not meticulously sealed against leaks. These unseen mechanical battles, fought inside dark plant rooms, sealed wall cavities, and microscopic carpet fibers, directly dictate the air quality breathed by every occupant inside. Surviving the Brisbane climate means realizing that a skyscraper is not a static steel shell. It is a breathing system that demands rigorous prevention, constant vigilance, and absolute mechanical mastery over its own microclimate.